In this video, we're going to review the answers to homework 6. Question 1. Write a vector in rectangular form that points to 2050 rather, to 0, 0, but has a length of 12. So first of all, we know that this vector is going to go from somewhere over here, 20 and 50. So let's say fairly large units here, 20, 50. Then it goes to the origin. So you know it's pointing kind of in the negative x and negative y direction. The vector itself is pretty easy to construct. So the vector what I want is minus 20 and minus 50. Okay, so that would be the vector that has 20 units in the x direction and 50 units in the y direction, both negative. But the length of this vector is not 12, right? Because we know by using Pythagorean theorem, this is 20 and this is 50. So therefore, the length of this vector, as I've constructed, it would have the square root of 20 square plus 50 square. So what is that? That is 400 plus 2500. Okay, so that would be the square root of 2900. That's its length. So how would I scale it to have a length of 12? Well, I'm going to simply divide this vector by the square root of 2900. Now that means it would have a length of 1, but I want a length of 12, so I simply multiply it by 12 back. Okay? So that would be the final answer. Part B, two different vectors in rectangular form that are perpendicular to the vector in part A and both have a length of 1. Okay, so first of all, let's identify a vector that would be perpendicular to the original vector. So there are two possibilities, right? One is pointing that direction, the other one is pointing the other direction. Okay, so let's figure out vector 1 first. So let's call it vector 1. What is the slope? Well, if it's perpendicular, it should have a direction of minus 50 and 20. Okay. And how do we know that? Well, you can verify the slope of this vector. The slope of this vector, slope of vector 1 would be what? Y over x, right? 20 over minus 50, so which is negative 2 over 5. And the slope, sorry for the misspell, slope of the original vector, and let's call that vector A, would have a slope of minus 2 and minus 5, right? So that would be minus 5 divided by minus 2, which is 5 over 2. And you notice if I multiply these two quantities together, I'm going to use orange to highlight. If I multiply this, it has a product of negative 1, which indicates that the slopes indeed perpendicular to each other. Okay, so with that, I want a unit length of 1. Well, simply, I already calculated the length of this vector, vector 1. The length as is described, it has a length of 2900. So I simply divide it by square root of 2900. Okay. Alternatively, I have vector 2. Vector 2. And vector 2 must have a direction of plus 50 and minus 20. Okay, so positive 50 in the x direction and negative 20 in the y direction. And similarly, I know the length of that vector, I already calculated, which is this quantity right here. So I need to divide that by that same quantity, and that would give me a length of 1. Okay, problem 2. y equal to mx plus b, something we're familiar with, linear form of an equation. Write down the general equation for the point slope form. Remember, the point slope form has a point that we want the graph to pass through, we want the line to pass through, and has a slope of m. And the general equation has the following form: y minus y0 is equal to m times x minus x0. Okay, we talked about that in class. Go back to your old notes, and basically is the transformation of the line, which is with the slope m, y equal to mx, and we grab this point, okay, that I highlight in red, 0, 0, and I want to transform it over so that it passes through a new point, x0, y0. Okay, so to do that, I basically shift the line in purple to the right by x0 units, and that gives me x minus x0. And then to transform up by y0 units, and that's what that minus y0 on the left. Knowing that when you move it over, it becomes a plus y0. Okay, so that's the general form that I've used the purple color to highlight. So now, given that, part B becomes super easy, right? I know the slope is 1/3, so m is 1/3. And my x shift is -3, which means x minus -3, so it becomes x plus 3. And on the left-hand side, it's y minus -4, which is y plus 4. And that's it. That's the equation. All right, part C. Given 2 points, I need to first calculate the slope. So what is the slope m? Change in y, which is 55 minus 5, over change in x, 30 minus 3. 55 minus 5, of course, is 50. 30 minus 3 is 27. Unfortunately, cannot be simplified, so that's fine. We'll use that number. And I can pick either one of these points to be my x0, y0. Doesn't matter. Okay? The equation will come out to be equivalent. So let's pick the simpler one. So I have my slope, 50 over 27. And my x shift is going to be 3 units. So x minus 3. And what about my y? My y needs to be shifted by 5. So y minus 5. Okay, that's it. Okay, so here we indeed can quickly come up with an equation using the point slope form. Okay, on the next question, I'm not going to bother reading the instructions again, so let's just start plotting the points. Let me draw the xy plane here. So this is x, y, x, and y. All right, point 1, 1. So that's pretty straightforward. Let's say 1 unit here, 1 unit there. So this is point A. 1. Let's go to B. So this is done. Let's go to B. 1 with the angle 45 degrees. Okay. So that means I have an angle facing 45 degrees and a unit of 1 length. So we know it's got to be, it cannot be here, right? This would be wrong because that implies a length has to be greater than 1, because, you know, if you have side length of 1 for a right triangle, then the hypotenuse has got to be larger than 1. So we know that cannot be the case. So where would that be? Well, we can draw a arc of a circle, and on that arc, every point on that arc would have a length of 1 from the origin, right? So I can confidently say now this is my point B. Okay, so point B is done. C is 3, 0. Let me switch to yet another color. So C30, 1, 2, 3, 3, 0. So that's C right there. Okay, what about point D? 3 at an angle of 90 degrees. Okay, so 90 degrees would be in this direction. I'm using green color now. 90 degrees from the positive x-axis and 3 units. So if I were to draw again an arc of a circle, I'm not a very good artist, sorry, then 3 unit length would be here. So that would be my point D. Okay, so D is done. Minus 30, part E. Let's go to minus 30. Switch to orange now. So minus 30, minus 3 over here. Y is 0, so that's point E. Point F, minus 3, but at 90 degrees. Now this time we have to be a bit careful. So let's start with the angle, 90 degrees. 90-degree angle is this way. Again, I'm using orange now. So the vector at 90 degrees is going to be pointing in that direction. But I have a length of minus 3. So minus 3 means I go backwards from the origin, okay, in the exact opposite direction. So I need to go this way for 3 units. So that this point now would be F. Okay, so that's F. Let's go to G. I'm running out of colors. Let's go to blue. Okay, G. 1 unit, length of 1 and minus 90 degrees. Okay, so minus 90 degrees would be going this direction in clockwise, 90 degrees. So again, my vector is now heading this direction. Okay, 1 unit. Well, okay, so 1 unit is right here. So therefore, this would be my G. Finally, H. Okay. When you have a length of 0, then it really doesn't matter what the angle is, whether it's 37 degrees or 0 degrees or 180 degrees or 9,000 degrees, doesn't matter, right? Because it's length of 0, so therefore it's right here at the origin. It's just a point. So this is my H. Okay. All right, on to question 3. Given this circular vector, so we notice right off the bat that this is comprised of a circle and a constant vector, 2, 3. Okay. So that means the center of the circle is at this vector, 2, 3. All right. So simply, the center is circled at the coordinate 2, 3 because the vector points to 2, 3. What's its radius? Well, when you have 3 multiplied with a unit circle that is described by cosine some value, comma, sine of the some value, that means its radius is 3. So radius is 3. R equal 3. Center equal to that. Okay. How long does it take for the point to make 1 full rotation? Remember what we talked about for a sine or cosine function to repeat itself. What we want is I'm looking for this quantity to be equal to 2 pi. Because when it's equal to 2 pi, that's when cosine repeats itself. Similarly with sine. So we can just pick one of them. So the equation I set up is simply t over pi is equal to 2 pi. So what must t be so that it is going to be pi? So t must be equal to 2 pi squared. Okay, it's weird, but that is how long it takes for the circle to make 1 full rotation. Okay. Since speed is distance over time, what is the speed of the point? Okay, so now we need to calculate what is the total distance traveled. Let's start with this. So distance is equal to the circumference, right? At a period, what I mean is when you have time t equal to 2 pi squared, then it travels one full circle. So that is the circumference, right? So distance must be the circumference. And the circumference is given by 2 times pi times the radius, which is 3. And the time it takes to travel that full circumference is 2 pi squared. So therefore, speed, simply dividing one by the other, is 6 pi over 2 pi squared. This reduced to 3. Pi and pi, one of the pi cancel, so it's just 3 over pi. So the speed is 3 over pi. Part D, if I want my point to move at 10 feet per second, what would k have to be if the points travel along in this vector? So let's take a look at what is the circumference of this circle based on k times the unit vector. Well, we know the radius is k, right? Because that's what that k value means. So therefore the circumference would be equal to 2 times pi times k. And what about the time it takes for a complete rotation? Well, it's the same value, right? What we see here is the same value as before. And we already calculated the period is t equal to 2 pi squared. Okay, so for the speed to be at 10, I need to set the distance over time to be equal to 10. And what is the distance over time in this case? Well, the distance over time is 2 pi k divided by 2 pi squared, and that's equal to 10. 2 and 2 reduce to 1. One of the pi's cancel. So 10 must be equal to k over pi. Therefore, k is equal to 10 pi. Okay, part E, if I want my point to travel 10 feet per second, what would R have to be if my points travel along this vector? Well, let's figure out what the circumference is. Okay, so given the radius of 3, the circumference is equal to 2 times pi times 3, 2 pi r. And the fact that it's r times t, what would be the period for a complete revolution? How long does it take to complete one revolution? Again, we go back to our original definition. I want this to be equal to 2 pi when t has elapsed for one full period. Okay, so therefore, in order for r times t to be equal to 2 pi, my t must be equal to 2 pi over lower r. Okay, now let's not confuse this r here with the radius. Okay, this is a different parameter. The radius is already given. The radius is equal to 3. Okay. All right, so now that I know the time period it takes to travel one complete revolution, and one complete revolution is the circumference, therefore the speed must be 2 times pi times 3, which is 6 pi, over the time period, which is 2 pi over r. Okay, I have a fraction divided by fraction, so I can just multiply by the inverse of the denominator fraction, so that becomes r over 2 pi. Pi cancels, this becomes 3, so it's equal to 3r. Okay, so based on these parameters, my speed is equal to 3r. But I want it to be equal to 10. So simple, I set 10 equal to 3r. Therefore, r must be equal to 10 over 3. Okay, and that's my answer. Okay, so it says the rectangular graph has negative y values for x between pi and 2 pi, and we can see that, right? This is the sine function turns negative whenever the angle exceeds pi. Why doesn't the polar graph have points in the negative y values? I intentionally make the polar graph a little bit larger so that we can see it. So let me switch down a little bit and use this to answer the question. All right. Okay, I fit both of them here on screen. Okay, well, let's take a look. Because the polar equation is r equal to sine of theta. Okay, and I talked about this, I think, in my tutorial lesson video, but let's take a look again at what happens when the angle goes beyond pi. All right, so from 0 to 90 degrees, that means within this range of the angle theta, okay, then my radius, radius meaning the distance in polar coordinate, okay, how far is my point from the origin, I call that the radius, means that how long is that length is of that vector, of that polar vector. The length is all positive, right? But once you go beyond pi, and let me switch to a red color now. Okay, so in this part of the curve, then you actually turns into negative. The length turns into negative length. So in other words, you can think of an angle that is beyond pi. So let's say I make this angle just a little bit beyond pi. Okay, this is my angle theta, but my r is going to be negative. It's going to be somewhere over here. It's a negative number. So that means I need to be tracing back. Let me use a different color just to indicate. So that means I need to be tracing in the opposite direction because it's a negative r for some distance. And if you trace it out, this is the distance. So what happens is that it actually maps right back into the same set of points as in this region. Okay? So in other words, you have two overlapping circles. One for 0 to pi, and the other one from pi to 2 pi. Okay? They're the same circle. So that's why you never see any value that is at below y equals 0. Okay, and we can now look at answer C. Highlight the part of the polar graph which correspond to angle values between pi and 3 pi over 2. So let's take a look at the angle first. So angle here would be pi, and angle here would be 3 pi over 2. All right. So in this region, my r, which I'm going to use vectors to show, these would be the vectors that are pointing in that angle theta, right? But bear in mind that all the r's in this region is negative. So therefore, again, going back to my orange, that means my vectors are all going to be pointing in this direction, okay? Directly opposite to it, okay? So if I were to highlight the part of the circle that correspond to the angle between pi and 3 pi over 2, it would be this part. Okay, then I'm going to be using my wiggly marker. Okay. Okay. So for cosine function is a little bit different. We have to kind of look at what the vector angle versus the r value. So if you look at angle 0 and then plot out the vector length, that would be right here. And then we plot, go to vector angle of pi over 4. That would be this right here. So that corresponds to this point. And then as it approaches 90 degrees, the vector length shrinks down to 0. So that would trace out the top half of this circle when the angle goes from 0 to pi over 2. As it goes from pi over 2 to pi, then it's going to trace out an angle that is beyond pi over 2, but the length is now going to be negative. Okay, so that means it needs to go in the other direction of the angle vector. So that's why it traces out this point here. And then finally at pi, it goes right back to the original value of 1. Okay, so if you are to trace out the full range of angles, different values of theta, you will be tracing our circle. In this case, the circle is lying to the right of the vertical axis. Okay, part B of the problem. Sketch the graph y equal to sine parentheses x minus pi over 4. We know from transformation that this is basically a horizontal shift in the x direction, right? And we are shifting by pi over 4 in a positive direction. Okay, whenever you have x minus a quantity, you're actually shifting to the right by that quantity. So let's plot out the original sine curve. I'm going to use a very light dotted line. So the original sine curve is like going from here to pi over 2, reaches 1, and then it goes to 0. And then I'm not going to do the whole thing. Okay, so that's the original sine of x. Okay, let's plot x minus pi over 4 and sine of that quantity. That is shifting this whole curve to the right by pi over 4. So my sine now looks like this. Okay, and it keeps going like that. So let's use the red curve. So this red curve is what that is. All right, and we use that red curve to figure out what the value of r is depending on the angle theta. All right, so I'm going to use, let me use green to indicate the direction of the angle, the vector of that indicates the angle direction, and then I'm going to use orange to indicate the length of r. Okay, so green and orange. All right, let's start at angle 0. So that means my angle vector is pointing straight right. What's the value of r? Well, let's take a look at r. When angle 0, angle r is actually back here, right? Angle 0 is actually down here. Okay, so it's a negative value. So that means it's probably back here somewhere. Okay. I'm going to use orange. So negative value means it's going to go in the opposite direction, and at minus 45 degrees, probably about 0.7. So it's going to be around here somewhere. Okay, indicate with the dot. All right, let's go to 45 degrees, pi over 4. My green vector at 45 degrees pointing in this direction. Okay, and what is my r value? Well, at 45 degrees, my r value is actually right here. So it's going to be 0. What about at 90 degrees at pi over 2? Okay, so my green vector is now at pi over 2. Okay, and at pi over 2, what is my r value? At pi over 2, my r value is here. It's roughly 0.7. Okay, so again, it's going to be roughly at 0.7. somewhere around here. And let's keep going with the green vector. Now the green vector rotates to 3 pi over 4. Okay, so that would be in this direction. And what is the R value? The R value is 1 right here. R value is 1. So that means it's going to be here. And as the green vector rather goes to 5 pi over 4, let's go to pi first. So let's go to pi. My green vector is at pi. My R value indicated by orange is going to be here. Okay, sorry, I didn't draw my sine curve very symmetrical, but it should be around there. Okay, so it's back to 0.7, which is right here. All right, and let's go to 5 pi over 4. So when the green vector, the angular vector, is pointing 5 pi over 4 direction, what is my R value? 5 pi over 4, my R value is 0. I'm back here. Okay. So it looks like if I trace out the orange, all the points, it looks like something like this. And if I keep going with my green vector, let's say my green vector now points to 3 pi over 2, then my orange value is down here, which is roughly minus 0.7. And you notice I have to go the other direction because it's a negative value. So my orange vector has to go back this way, which overlaps with the original value at pi over 2. So in other words, it's going to trace this circle twice. Okay, but it's the same circle. Okay, as you complete the whole 2 pi of angular change. So what do we observe here? What it looks like is that the original sine function, if it were r equal to sine theta, the graph was like this. And now when the angle becomes angle minus pi over 4, it looks like it's rotated counterclockwise by pi over 4. So instead of a translational shift in the x direction, in the case of a Cartesian function, in a polar function, when the angle is subtracted by a constant, that results in an angular rotation of the original curve by that same amount. Okay, so what transformation is going to be an angular shift rather than a horizontal shift? Now it's an angular shift, and it's an angular shift in the counterclockwise direction by whatever that amount is. Okay, by that, if it's theta minus c, it would be rotated counterclockwise by the same amount, c. Okay, assuming c is in radian. Okay, for the learning problems, I'm not going to give the final answer, but I'll give you some hints as how to think about it. We know what the graph of this looks like. It's been repeated multiple times. So r equal to sine theta is going to be a circle that has a diameter of 1. What happens if we make it to be absolute value of sine theta instead? Well, you recall when we trace out this circle, when the angle is going from 0 to pi, you trace out this circle that I just put in purple. And when you trace out the circle, trace out the angle going from pi to 2 pi, which I'm going to use in blue, the original function just make it overlapping because r turns negative and it maps back right on top of the original circle. But if you put an absolute value over it, then r is no longer negative. So what happens is that the blue circle is no longer overlapping with the purple circle, but instead is going to be something like this. Okay, and you can check it out in decimals. And why is that? Again, the key fact lies in the fact that the sine function from 0 to pi is positive, and from pi to 2 pi is negative. And if this gives the value for r, and when r is negative, then it actually overlaps back to the original circle. But when you make r equal to absolute value of sine, then what you're doing is that I'm going to use dollar line. What you're doing is that you force this to be positive also. Okay? So that's pretty much the answer. Okay, let's talk through the last question. So we all know what the reciprocal function looks like, y equal to 1 over x. And it turns out r equal to 1 over theta is a spiral. Okay? And it's a spiral that as theta becomes smaller and smaller, then r becomes larger and larger. So you can imagine when theta gets very close to 0, that means r is approaching infinity. Okay? So this point actually may be counterintuitive, this is when theta is very small. But when theta is large, on the other hand, when theta is very, very large, then r becomes very, very small. So when theta approach infinity, then r approach 0, right? That's the reciprocal function. So when theta approach infinity, then r becomes, it just keeps spiraling in and closer and closer and closer to the origin. All right, so let's answer the first question. When theta is equal to 1, r is equal to 1. That is true. So why isn't 1, 1 a point on the polar graph? Well, simple, because when theta is equal to 1, that means it is at an angle of roughly 1/3 of a pi. So it's, if I'm going to use my blue to indicate the angle vector, so this is roughly 1 radian. Okay, and r is equal to 1, so the radius of 1. So it's going to be somewhere over here, probably. Let's say that is 1 unit. Okay, but that doesn't correspond to anything close to the value of 1, 1, right, on the xy plane. What value is theta causing the graph to create a spiral? So I just explained that. Basically, the spiral is caused by the fact that as theta increases, becomes larger and larger, then r becomes smaller and smaller. What values of theta causing the arm that branch out to the right? Well, as I said, it's because when theta becomes tiny and a very tiny quantity. What do you think about 1 over x horizontal asymptote mean for the polar graph? How do you think about what is vertical asymptote mean for the polar graph? Okay, well, the horizontal asymptote for the y over x curve means when x approach infinity, then 1 over x approach 0. All right. Now let's think about the equivalent. When theta approach infinity, then 1 over theta approach 0. And that's right here. Okay. So instead of an asymptote, what you have is an asymptote point. Instead of an asymptote line, it's an asymptote point. And you might call that point of convergence. Okay, so it basically converges into a single point. So the equivalent of an asymptote, horizontal asymptote, would be a point of convergence. What about the vertical asymptote? Well, the vertical asymptote, let me switch to a different color in this graph, is when x approach 0, y approach infinity. Okay? So equivalently, when theta approach 0, then 1 over theta approach infinity. So what does that mean? When the angle theta is close to 0, so angle theta close to 0 is this angle right here. Okay? That means my r gets to be super, super large. So in fact, based on this diagram, angle doesn't even have to be nearly 0, but my r is already getting pretty large. So you can imagine the r, how long it would have to be. It would have to be off page as the angle becomes smaller and smaller. So it will never, this spiral would never touch the x-axis. Okay?